Hello, welcome back once again. Today we have another interesting indefinite integral from MIT Integration B 2025. We have to evaluate the integral of 1 over x root of x squared minus 9 dx. So in this video, I'll be presenting two different methods. For my first method, we're going to make use of trigonometric substitution. So let's start with our first method. For my first method, we're going to call this integral I. That is the integral of 1 all over x multiplied by the square root of x squared minus 9 and then dx. So we're going to let x equals, remember that x here, let us recall from this trigonometric identity that the secant squared of theta minus 1 is equal to the tangent squared of theta. And here we have x squared minus 9. So if you let x equals 3 secant of theta, if you square both sides, you will see that x squared will be 9 secant squared of theta. So if we have 9 secant squared of theta here, we can factor out the 9, and then we'll be left with secant squared of theta minus 1, which is tangent of theta. You get the idea? Okay, now, so from here, we get that dx is equal to, this is 3 secant of theta multiplied by the tangent of theta and then d theta. So that is the derivative of 3 secant of theta. So our I, in terms of the secant of theta, so our I is going to be the integral of 1 all over, so here x is 3 secant of theta multiplied by the square root of x squared will be 9 secant squared of theta and then minus 9, right? And here dx is equal to 3 secant of theta multiplied by the tangent of theta, and then we have our d theta. Okay, so from here I think we have some nice cancellations going on. This and this, right? So here our I is going to be equal to the integral. So we're going to have 1 all over. So inside this radical, we can factor out 9 because it is common, right? So we're going to have the square root. So if you take away 9, then we have the following: secant squared of theta minus 1, right? And then we have the tangent of theta and then the theta. So this is going to be equal to the integral of 1 all over, so here this is same as square root of 9 multiplied by the square root of secant squared of theta minus 1 will give us the tangent squared of theta. And here we have the tangent theta and then d theta, right? Okay, cool. So from here now, we have I is equal to, now we know 1 over root 9 is same as 1 over 3. And then multiplied by the integral of, this will be 1 all over square root of tangent squared of theta will give us the tangent of theta. And here we have the tangent theta and then the theta. So this and this get cancelled. And here we're left with 1 over 3. The integral of 1 with respect to theta will give us theta, and here we have plus c. Now let us recall, remember our answer needs to be in terms of x. That x is equal to 3 secant of theta, right? Divide both sides by 3, we get x over 3 is equal to the secant of theta, right? Now take the inverse secant on both sides. So we're going to have that theta is equal to the inverse secant of x over 3, right? So we substitute this for theta here, and boom, we have our solution. I is going to be equal to 1 over 3 multiplied by the inverse secant of x over 3 and then plus c. So this right over here is our solution. Now let's go to our second method. So for the second method, remember our I is equal to the integral of 1 all over x multiplied by the square root of x squared minus 9, and then we have our dx. So this is going to be equal to the integral of 1 all over, we have x here, right? So here we're going to have the square root. We're going to have the square root. Then we factor out x squared here. Then we're going to have 1 minus, this will be 9 all over x squared, right? And here we have dx. So from here, we're going to have the following. Our I is equal to the integral of 1 all over. So here we have x, right? We have x here. And then there's something really cool about this place, right? Remember that is same as square root of x squared multiplied by the square root of 1 minus, now 9 over x squared is same as 3 over x whole squared. And then we have our dx. Now we know that the square root of x squared is equal to the absolute value of x, right? Now, if you think about x being greater than or equal to 0, then we're going to have our square root of x squared to be equal to x. Okay? So, assuming that x is greater than or equal to 0, then our integral I is going to be equal to the integral. So, we're going to have 1 all over. So, x times x will give us x squared, right? And here, multiply by the square root of 1 minus, so remember what we have here is 3 over x whole squared. And then we have our dx. So make the following substitution. We're going to let 3 all over x equals t, right? Differentiate both sides, we get negative 3 all over x squared is equal to, oh, this is dx, right? So this is equal to dt. Now divide both sides by negative 3, we get that dx all over x squared is equal to negative dt all over 3. And when we know this integral I, we can write it as the integral of 1 all over, then we have the square root of 1 minus, this is 3 over x whole squared. And then we're going to write this as the x over x squared. So we can see the x over x squared is equal to this, right? So that makes this integral really cool. So our I is going to be equal to the integral of 1 over, so this is square root of 1 minus t squared. Dx over x squared is equal to negative dt over 3. So this is going to be equal to negative 1 over 3 multiplied by the integral of 1 over the square root of 1 minus t squared and then dt. Now, with the standard integral formula for the inverse sine function, so I here is going to be negative 1 over 3. So this integral here is the inverse sine of t, right? So this is going to be the inverse sine of t and then plus c. Then the question here is, what is our t? Remember, we let this 3 over x equals t initially, right? So we replace t with that, and boom, we have our solution that this is equal to negative 1 over 3 multiplied by the inverse sine of 3 all over x and then plus c. So this right over here is also a solution. Thank you for watching. Please, if you really enjoyed the video, kindly subscribe to this channel. Also like, comment, and share.